अस्सलाम वालेकुम। आज का हमारा टॉपिक है कंपैरिजन ऑफ सेवरल पॉपुलेशन मीन्स एंड up till now we have discussed testing of hypothesis for one population comparison or two independent populations or matched samples. Now let us move to the situation when we wish to compare more than two independent populations. In this case our hypothesis is null hypothesis mu1 is equal to mu2 is equal to so on up to mu k, means there are k groups and all the groups have equal population mean. Or we can also state this hypothesis in this way, that all the population means are equal, and alternative hypothesis against that will be at least one population mean is different. When we perform this, we have to decide then our level of significance. So there are three possibilities, as we have discussed that several times, that we can take alpha at 1% or 5% or 10%. The next step is deciding the test statistic. So the test statistic is depending on again the normality condition. If our data is normal, we are going for further testing of variances homogeneity. If the variances are homogeneous, we will go for one-way ANOVA. If variances are not homogeneous, we will go for robust test, also known as Welch test. Then, if data is not normal, we will go for the Kruskal-Wallis test. And then the simple way of conclusion is same as before. If significance value is greater than your specified alpha, we will accept H naught, and if our significance value is less than our alpha, we will accept H1. And if H1 is accepted, automatically means we are saying that at least one population mean is different. So we have to identify which population mean is different from the others. And for that purpose, we perform multiple comparison test, also known as post hoc test. अगर हम ANOVA अप्लाई कर रहे होंगे, if we have implemented ANOVA, we will go for LSD test. In case of Welch test or robust test, we will go for Tam-Henne test. And in case of Kruskal-Wallis test, we will go for the non-parametric table of multiple comparison. So today's our example is regarding, here we are performing an analysis of smokers non-smokers and those who have quitted the smoking about their time of sprint they take to complete run for 500 meters or say 1 kilometer. So let us open the data in SPSS. We have already a data last time we have used and this sample data. So this is the variable sprint, and this is the variable of smoking. So in this data, whole data, these two variables are of our interest. So this is the numerical variable or dependent variable, and this is the grouping variable. So first I am going to check the normality, and to perform the normality test, you know how we will go. We have done that several times. So I have to shift sprint in the depend test field, and then I will go with testing, customize test, and here I choose Kolmogorov-Smirnov, and then I press run. So these are the results of normality. So here I will first state my hypothesis about the normality. Data is normal, and then I will state the hypothesis against it, the alternative hypothesis. Data is not normal. And we can see here, this is the table of one sample Kolmogorov-Smirnov. I am copying this in the Word file, and here it is. So the significance value you can see here, this significance value, and this is clearly less than your alpha value. So we will say that significance value is equal to 0.000 is less than your 0.05. So we will accept the hypothesis that data is normal, not normal, sorry, is non-normal. So since data is not normal, according to our this table, we will go for Kruskal-Wallis test. But just for the understanding purpose, I am going to perform all the tests I have written here. So first I go for analyze, compare means one-way ANOVA. From here I shift sprint into the dependent list and smoking as the factors. In the options I am going to choose homogeneity of variances, descriptives, Welch test, continue. In the post hoc test I am going to choose LSD and Tam-Hannes T2, and then I press continue, and here I go for the OK. So these are the descriptive summaries. We have several times interpreted that. So I am going to quickly tell you that there are 261 people who are non-smokers, and their average time of sprint is 6.4 minutes with a variation of 1.25. 33 persons who have quitted smoking have average time of 6.8 minutes, and similarly the 59 persons who are smokers have average time of sprint 7.12 with a variation of 1.08. So here it is the test of homogeneity, and from here I can take any one of these based on mean or based on median or based on median and with the adjusted degree of freedom. So I am going for the first row, that is based on mean, and the significance value is 0.09, which is greater than our specified alpha. So the next test will be, our hypothesis will be, next hypothesis will be that variances are homogeneous, and against that H1 will be variances are not homogeneous. और इस केस में मैं ये इस टेबल को यहाँ पे कॉपी कर लेता हूँ, and here it is. So I have copied this here, the output for this, and this is so we will say that the significance value on the basis of mean is 0.091, which is greater than 0.05, which is your alpha. We will accept H naught and conclude that data is homogeneous. Now, since the variances are homogeneous, now we are coming to our main hypothesis, and the main hypothesis that sprint time for all three groups is same, while H1 here is sprint time for at least one group is different. ये हमारा H1 आ गया. अब मैं यूज़ करूँगा जिस टेबल को इसके टेस्ट करने के लिए, that is ANOVA table, and here it is. So from the ANOVA, the significance value from ANOVA table we have F is equal to 9.29 with significance value is equal to 0.000, which is less than 0.05, leads us to the acceptance of H1, that at least one group has different sprint time as compared to others. And to identify which group is different, we will jump towards this, and from here I will now interpret the LSD as I have used ANOVA. So from multiple comparison table I will use LSD, and LSD I will compare 0, 1 and this significance value, and you can see that the very first group is this one, 0, 1. So that is significance value is 0.0858, which is greater than 0.05. So there is no significance difference between group 0 and group 1, means non-smokers and who have quitted the smoking. Then the next comparison is between 0 and 2, and the significance value is 0.001, which is less than 0.05. So that means group 0 non-smokers and group 2 smokers are significantly different from each other. Then the next comparison will be between 1 and 2, and again significant value is 0.277, which is greater than 0.05. That means those who have quitted the smoking and those who are smokers are not significantly different. इसी तरह से अगर मेरा फॉर एग्जांपल होमोजेनिटी ऑफ वेरिएंसेस वाला सिनेरियो has failed and I have accepted H1 and concluded that variances are not homogeneous, then rather than ANOVA, I will go to this robust test of equality of means, which is Welch test, and here the significance value will give you the conclusion about the acceptance of H0 or rejection of H0. In case of acceptance of H1, I will go to this Tam-Henne test, and again I will make comparison pairwise, 0-1 comparison, 0-2 comparison, and 1-2 comparison. And according to their significance values, I will conclude the results. But in this case, as we know that normality had failed, so I will go for non-parametric test, and that is independent samples. In the fields, I will choose sprint in my dependent list, and in the grouping variable, I have to choose smokers. Now in the settings, I will go for customized test, and from here I will perform Kruskal-Wallis test, and you can see that there are multiple comparison tests also available. I will run. This will give me this output, and from this output, this is the Kruskal-Wallis test summary, and the significance value is less than 0.05. So I will go for multiple comparison, and this is the multiple comparison for in the case of when we are performing Kruskal-Wallis test. And this is a graphical comparison as well, and one can say that there is no much difference in 0 and 1, but 0 and 2 are significantly different from each other, as their average is 7 and the other's average is 6.5 around. Similarly, here the central line of this box plot is closer to this line, so they are not significantly different, and also concluded from these significance values where the comparison between 0-1 group, 0-2 group, and 1-2 groups are made. So that is as far as ANOVA is concerned. So you have to make sure that first of all you are performing normality test, and then according to this table you have to decide which test is suitable, and then you go for that. In this lecture I have performed all the tests for the understanding of availability of options. Thank you very much.